When you configure DHCP, the primary component you work with is a DHCP scope. This scope contains all the IP information. When I create a scope, I get a wizard and you just walk through the wizard. It'll ask you all the questions, but you have to name your scope. Now, usually that's associated with a location, most common, because you can have multiple scopes on the same server. You can have multiple DHCP servers. So usually something user-friendly. The range of IP addresses. I'm going to define the start address and the end address, and all the addresses in between those will be issued out to our clients. We also have to define a subnet mask. Now, these three all say mandatory because you have to fill those in yourself. Everything else has like default value, so you have to go through these others here, but they will default. Exclusions. Now, by default, we don't have any exclusion, so you can just skip that if you want. But what an exclusion would be is a range of addresses that I do not want to hand out. Now, it could be one address. For example, if my scope starts at 10.11.25 and it ends at 10.11.200, but I know on the network that we use addresses that end with 100 to 105, I'm going to use those for some other purpose. So whatever the reason, I do not want DHCP to hand out those addresses. I can simply have an exclusion that says 10.11.100 through 10.11.105 will be excluded. They will never be handed out. So you could do just one address up to a range of addresses. And you could have multiple exclusions if required. But those are just addresses that are not going to be issued from your DHCP server. You can also build in a delay. Typically, you would build a delay if I wanted some type of fault tolerance in DHCP. If I have my DHCP server and all your clients get addresses from the DHCP server, you have some concerns about single point of failure. So the solution, have more than one DHCP server. So we'll call this DHCP-A, and we'll call this DHCP-B. Both of these servers are configured with valid IP addresses. So maybe this one leases this range of addresses, 25 to 200. Maybe server A leases those addresses. Maybe server B leases 10.11.201 through 10.11. I'll say 254. So they do not lease overlapping IP addresses. But if either one of those gives you an IP address, you're on the network connected to resources, so you're fine. If DHCP server A were to crash, no big deal. You just get an address from DHCP-B, you're still on the network. Well, if I want DHCP to be a backup server, meaning I really don't want you to lease addresses from this server. Maybe it's also a file server. I want you to lease addresses from DHCP-A. The only time I want you to lease an address from DHCP-B is if A does not respond because it's offline for whatever reason. Well, if I want to do that, I can simply, when I create the scope, I can define a delay. Now that's just a number of milliseconds that once this hears a discover, it's going to wait the number of milliseconds I specify before it sends the offer. Theory would be this DHCP-A would have sent an offer first. So you would always take that offer that was sent from DHCP-A. If it never responds, then eventually, after some time, you would get the offer from DHCP-B. So just to function as a backup server is the sole benefit of building in a delay. We also can define the lease duration. Now, the default is 8 days. You can set it to whatever you like. Many environments will set it to be less than that. That is just nothing but the amount of time that says when DHCP leases you an IP address, it will hold on to it for that number of days. So if you show up Monday morning and connect to the network, I give you an address, you leave at lunchtime Monday and you are never going to return to this office. Does not matter. For the next 8 days, DHCP is going to say, I'm holding this lease for this computer. I'm not going to give it to anyone else. The only concern there, You want to make sure your lease duration is not so long that you would exceed the number of computers on the network. Quick story. I had a client, I don't know why, but whoever set it up, they were actually using a Linksys router. It was a very small network, and they were just trying to modernize the network. But on their Linksys router that was running DHCP, and works like a Windows DHCP server basically, they had a 90-day lease. Now, they had about 20 users, but the problem, they had a lot of guests that would show up periodically. Other devices like smartphones would get connected to the network. So their problem, even though they had a small number of users on the network, anytime it leased an address, it would say, I'm going to hold this address for you for the next 90 days. The problem ended up being they had so many devices connect to the network within a 90-day period that they exhausted all the IP addresses that DHCP could assign. Now, never at one time did they exceed the number of devices on the network, but DHCP would just say, hey, I'm still holding this address for this computer from 75 days ago. I have to hold it until day 90, so I can't give you this address. Simple solution. Go to that device and just shorten the lease duration. Completely solve that problem. Have no idea why anyone would set it to 90 to begin with. Can cause that problem. Now, we also have options. Options would be additional information that you want to be leased. For example, I want you to have a default gateway assigned. Well, when we went to the IP address range here, all I assigned was the start address and the end IP address. But I also want you to have a default gateway so you can connect to the network. I want you to have a DNS server so you have name resolution. Well, that would be option 3, the default gateway. DNS servers would be option 6. I also typically will define a domain name, option 15. So when you type something like ipconfig or ipconfig/all, you'll see your domain name show up in that list as well, gets appended to your computer name. So these are the common options that you will define. Now, there are dozens of options that show up, but most have very specific purposes, but these you're going to have in every environment. Your home network, assuming you're using some type of DHCP, like a Linksys, Netgear router, or some router from your internet service provider, it's going to run DHCP. It's going to lease addresses to all the devices in your home, and it's going to actually have a gateway, DNS servers, and domain name defined, and it's going to lease all that out to you. A quick example, the computer I'm using right now, I'm just going to type ipconfig, if I could spell, /all. And if I look in this computer, I can see my DHCP server is 192.168.1.1. I can see the default gateway, 192.168.1.1. We will for now ignore this FE80. That is IP version 6. But I can see the IP address. I can see the subnet mask. I can see this lease is actually only a 1-day lease. It was obtained March 2nd. It will expire March 3rd. So when that hits 50%, it's going to automatically renew. Pretty fascinating. The only other option is activation. Once I create a scope in DHCP, I can activate the scope. Now, a scope can only lease addresses when the scope's been activated. At any point, you can come back and deactivate it, and effectively, you just turn it off, and it does not lease IP addresses. So, activate, deactivate is an option for any of these scopes we create. One of the concerns with DHCP is that we have a rogue DHCP server. So, in DHCP, before or after you create your scope, we want to authorize the DHCP server. When you authorize a server, what it actually does is communicate with Active Directory domain services, and it adds itself to an authorized list. Now, you could do this through PowerShell. Add-DHCP server in DC, just the name or IP address of your DHCP server. You could also do this in the DHCP console, which is most common. You just open DHCP, right-click, there's an option to authorize. We'll see that in the interface. The point of this is to stop these rogue DHCP servers, meaning If somebody went to some server for whatever reason and installed DHCP, maybe to look at something, or maybe they plan to use it in a test environment or something like that, but it gets connected to our production network. If that's true and it's not authorized, it will never lease IP addresses. Also, an interesting fact, if you have a standalone server, meaning it's in a workgroup, not even joined to the domain, but you configure DHCP on it, it will not lease IP addresses if it detects another DHCP server and that DHCP server is authorized. So if you're on a network without a DHCP server, like a home network or something, and you just install Windows Server, configure DHCP, works great. If you have an Active Directory domain and an authorized DHCP server, your standalone will assume it's a rogue DHCP server and will never lease addresses, and there's nothing you can do about it other than join it to the domain and authorize it. Now, this only applies to Windows DHCP servers. If you have a non-Windows DHCP, like some type of router, access points can also run DHCP, even some switches, like enterprise switches like Cisco can run DHCP. Any non-Windows device, it will function regardless of authorization because they don't read Microsoft's authorization. That's just a Windows setting, the authorization. But let's take a look at creating a scope and authorizing our servers in DHCP.